The aim of the lab is to use Granta EduPack to select materials with multiple requirements for a specific application and to use the Eco-Audit tool to assess the energy demand and carbon dioxide footprint of a product in each phase of the life. Again, we are using the same software, Granta EduPack 2020. We'll start with the task 4.1, exploring the properties of well-known materials. In this task, you will be assigned a list of well-known materials, and we need to define our own material subset. Then we'll plot the graphs and identify materials for a specific property requirements, and we'll fill the findings in table 1. In this task, your demonstrator will assign you a material subset. Here we have 4 material subsets. You only work with one of these. So now we'll see how to define a material subset in the software. Here we are using the level 2 for the task 1. So I just click on the level 2. And I'm going to create a new project. For defining a material subset, you need to click on this chart select. So we click on that. Now we need to define our own material subset. So when you click on the select form, you can define your own material subset. So when you click on that, you will open this window, and inside these folders, you can find the 10 materials that you have in your list. For example, I am opening this ceramic and glass folder, and if I want to select a glass, that should be in the glass. So I can select whatever the glass that I have in my list. So I just select one, silica glass. If I want to select a metal, that should be in the metal folder. So I'll open the metal folder, and if I need a ferrous metal, I can open that one, and I can select the metal that I have in my list. For example, I am just clicking on the stainless steel. Likewise, you have 10 materials in your list, so you should be able to select the 10 materials. And after selecting the 10 materials, you can click OK, and those 10 materials will be on your list. So in my case, I have selected only 4 materials, then I can see these 4 materials in my left-hand side of the screen. Now we'll see how to select the materials with different properties. If we go back to our lab notes, after creating your own material subset with the 10 materials that you have in your list, we need to plot 4 graphs. So the first graph is Young's modulus versus the density. Second one is carbon footprint versus the price. Thermal conductivity with the electrical resistivity, and the fourth one is fracture toughness versus the yield strength. After plotting the graphs, we have to answer these questions. So we need to select the material with the highest density, material with the highest CO2 footprint, material with the lowest thermal conductivity, and the material with the lowest fracture toughness. First, let's see how to plot the graphs. We'll go back to the software. For plotting the graphs, we select this chart index. Now we can select our x-axis and the y-axis. So in our first graph, y-axis should be Young's modulus. So the category is Young's modulus is a mechanical property. So we select the mechanical property under the category, and the attribute is Young's modulus. So we select the Young's modulus. So we can keep the graph linear, and now we'll go to the x-axis. X-axis is the density. Density is a general property. We can select the density for the x-axis. Again, I'm selecting the linear. When I click OK, I can see the graph for the Young's modulus versus the density. Next chart is carbon dioxide footprint versus the price. So we select primary material, production energy, carbon dioxide, and water. then the carbon dioxide footprint production. So again, I'm clicking the linear, then go to the x-axis. X-axis is price. Price is a general property, so I'll click on the price general property and select the price. Again, I'm clicking on the linear. When I press OK, I can see my 4 materials in the graph. Third chart is the thermal conductivity, so it's a thermal property. And the x-axis is electrical resistance. So it's electrical property, electrical resistivity. So I think I've forgotten the linear, so we'll click on linear. So I can see my materials in the chart. The fourth chart is fracture toughness, which is again a mechanical property. And linear. The x-axis is the yield strength. It's again a mechanical property. So yield strength. Now we have plotted the 4 graphs. Now we can use this information to answer the questions in the table 1. In the table 1, first question is for finding the material with the highest density. So you have 10 materials in your subset. You need to find the material with the highest density. There are 2 ways to do that. You can click on the chart and you can select the material with the highest density. Your density is in the x-axis, so you can select the material with the highest density, which is, in my case, it is stainless steel. Or else, you can arrange your materials in ascending order or the descending order of the density. So when you go to the results section, you can select the stage 1. Stage 1 is Young's modulus versus the density chart. So I click on that. Then I can arrange them in the density, rank by density. So when I do that, density is in x-axis, so I can see stainless steel has the highest density. So likewise, you can use the graph, or else you can arrange your materials in ascending or descending order, and you can find the answers for the table 1. In task 4.2, we are going to select a material for a heat sinks of a microchip. In this task, you are requested to find a material that have a maximum heat flux per unit weight for an application of heat sinks. You need to follow the material constraints summarized in the table below. Select a material from Granta EduPack level 2. So we are using the level 2 materials, and use the tool limit. So we are going to use the limit tool to include the constraints, and you have done this in your lab 1. And then we use the graph to find the material with the highest thermal conductivity. The 3 constraints that we have are here. So the first one is electrical property. So you use the limit tool and set the electrical property as a good insulator. The second one is maximum serviceable temperature. Maximum serviceable temperature should be more than 150 degrees Celsius. So you can set these 2 requirements or the constraints using the limit tool. And then you can draw a graph. You can draw a chart and you can find the materials with the highest thermal conductivity among the materials in level 2. Then you can find and write the name here. In 3, we need to select processes for making plastic bottles. In this task, you will be assigned a design requirements by your demonstrator. You are requested to use the database of Granta EduPack level 3 and identify the processes that could be used to make plastic bottles. So these are the 4 requirement sets. So one of these will be assigned to you during your online class. So here we have given the material class, the process class, shape class, mass, minimum section thickness, precision, and the batch size. So you will get different data sets. So now we'll see what we have to do with this data set. For example, I'm going to take this design A. So after doing this one, we have to fill the table 3. So this is the information that we need to collect. So we need to find out the number of processes that pass the stages. So here they have given us 4 stages, stage 1, 2, 3, and 4. We need to find out how many processes pass these stages. So we have 4 stages and all stages together, and the name of the process, we need to write this process, the name of the process here. So in the first one, we need to find the number of processes which satisfy the mass range and the material class. So our mass range here is 0.02 to 0.4, and the material class is polymer thermoplastic polyurethane. So we'll see how to do this one. So when you go to your EduPack software, we select the level 3, and we are using the chart select here because we are going to find out the processes. So you can start with the material universe or the process universe, but I'm going to start with the process universe, and we are finding shaping processes. So there are altogether 146 processes. Now out of this 146, we need to find the number of processes which passes the constraints given. So the first constraint is mass range versus the material class. So the y-axis, we are going to plot the mass range. So if you click here, you can select the mass range. And you have given the mass range, so you can set the minimum and the maximum. I just leave it as it is, but you can put the values in which is given to you. So in the x-axis, now we need to select the material class, thermoplastic polyurethane. But here, when you click this attributes, you won't be able to find the material class because we have already set the process universe to shaping processes. So to select material here, we have to go to advanced and we click the tree and we change this process universe to material universe. Then we have all the materials here. We only need to select the thermoplastic and polyurethane. So you can expand this thermoplastic and you can find the polyurethane. So here the polyurethane, when I click insert, I can see that name, the material universe, polymer, plastics, elastomer, plastic, thermoplastic, and if you go further, you can find this polyurethane. Okay, now I press OK. So that's all set. When I press OK, I can see the chart here. Now here in the results section, I can only see 20 numbers. In your case, that will be different depending on your mass range. So this number you have to write down in your table 3. Now then we have to set the second stage. So we have to unclick this one first. I unclick the stage 1 and then I make the stage 2. So as you see here, when I unclick the stage 1, again I am going back to my main process, all the processes. It's 146 processes. Now out of this 146, I have to select the number of processes that pass the stage 2. Again, I'm going to the chart index, and here again we have y and the x-axis. So in the stage 2, the y-axis should be the thickness. So when you click here, the range of section thickness, you can set your thickness range here as the minimum and the maximum and go to the x-axis. Then you can select the shape, 3D hollow. Then you press OK. Now you can see out of this 146, 69 passing that stage. So your number will be different depending on your thickness range. Again, I'm unclicking this stage 2. When I unclick the stage 2, you can see I again get this 146, the total number of processors in the level 3. These things can be done using the chart tool, and also you can use the limit if you want to. So we have done the stage 1 and 2 with the chart, and now I'm going to show the same thing with the limit tool for stage 3, but it's up to you. If you want to use the chart again, you can do the chart. So when I click on the limit now, again I can put my constraints here. In our stage 3, we have to use the tolerance. So tolerance is a physical attribute. We can set the tolerance. For example, I'm putting 0.4 minimum and the 0.4 maximum, because the tolerance is just a number. It's not a range in our case. Then I need to set the process. So I go to process, and we have to select the primary and the discrete. So I'm clicking both. Now when I press apply, you can see there are 42 processors out of 146 total processors. Then now stage 4, again I'm going to use the limit tool. As I told you, if you want to use chart, you can use chart. So I'm going to the limit and economic batch size versus the process. So economic batch size should be under the economic attribute. So you can set the economic batch size. Again, if you have just one number, for example, if I put 50,000, if I want to make 50,000, I put 50,000 in the maximum and the minimum, because in our case, we don't have a range, we have a certain number here. And the process, so when I go to the process, again, it's primary and discrete. When I press apply, I get the number here, which satisfy those two constraints. So you can fill this information in your table 4, and in the table 3. In the table 3 again, there is a section that you need to, they're asking you to find the number of processors which satisfy all the stages. So I click all the stages here. Now you can see my tick here for all stages. So you can see there are only 2 processors which satisfying all the conditions. So you can write the number, and also you can find the name of those processors underneath here. So that's all you have to do in the section 4.3. In section 4.4, we are going to use some saved data to find information. So we are going to do an eco-audit of a product. In this task, you will use the Eco-Audit tool in Granta EduPack to access the energy consumption and CO2 footprint of a product in its life cycle. You are requested to interpret the results from an Eco-Audit project of bottled water, make changes to the input parameters to access how they will affect the results, and compare the results of bottled water with the bottled made with different materials and answer the questions. So these are the things that we need to do. We are going to open this file, which is in your C drive, program files, and Granta EduPack samples Eco-Audit EN. And this is under the level 3 PET bottles. After opening this file, we need to do few things as mentioned here. Let's first open the file. So when you go to the Eco-Audit here, you can open the existing file. So this file is in your C drive, and under the program files and Granta EduPack 2020 samples Eco-Audit, and we use this EN. So we need to open the file for level 3 PET bottles. Okay, so you have the information here which you need to use for answering this question. First, see what we need to do. So click the button for reports. So we need to search the reports and we need to find out the phase of this process of life contribute to the largest energy consumption and the CO2 generation. Which phase is contributing to this largest energy consumption and the CO2 generation? What is the material contribution to the CO2 footprint of the life cycle in kilograms? Click product definition. So the previous one was the reports, and now we are going to the product definition. Change the end of life choice for bottle from recycle. So we are going to change some information. So we are going to change the recycle to combust and click the report, and we are going to again find some more information. How much CO2 in the total is now released to the atmosphere by this end of life's choice. Then we are again going to the product definition and change back the end of life bottles to combust. Again, we are changing this combust to recycle, and then read the total release CO2 from the report. Then click product definition again and change transport from this to air freight, and we are going to find how much of CO2 in total compared with the previous reading. Finally, given other conditions are the same, in order to change the material of the bottle from PET to glass. So soda lime, this glass, we are going to change the material now from PET to soda lime. And the cap from polypropylene to aluminium, this aluminium type. Click open and follow the above folder to open. So you can either open this new file or else you can change this data in your previous file. Let's see how to do this part. So in this open project, you can see the product definition here and the report here. So in the product definition, you can see all the information about the product. In some of our questions, we need to change some information. So whenever you want to change information, this is where you are clicking. So if you want to change this, the bottle end of life, whether it is recycle or combust, you can do that change here. And also, if you want to change any material, you can click on the material and you can go and select whatever the material that you want to change. So in one of our questions, we need to change the material for to glass, or else you can open the glass stored data. And if you want to change the transportation, so as you see here, the transportation is here, 14 tons. So if you click here, you can make it to ocean freight, coastal freight, river, rail freight, or whatever you want. In one of our questions, we need to make it to air freight. Okay, now we'll see in the report what we can find. When you click on the report, you can find all the information. So here, and as the first information, we have the energy and CO2 footprint for different phases: material, manufacture, transport, use, disposal, etc. So here, this orange is for energy and the purple is for the carbon footprint. In one of our questions, they're asking us to find the phase which has the maximum energy, highest energy, and the highest CO2 footprint. So it should be the materials. So likewise, again, you can find the information here as well for the energy, the total energy. If you want to find the end of life potential, the energy, or else the total energy. In one of the questions, they're asking us to find the total energy by changing different variables in the product definition. So by changing the material phase to recycle, and also changing the transportation for air freight. They're asking us to find some information, so you can find those information under the report. So with this, I think you can do the rest by yourself, and I wish you all the best.